My object was s1.name Harry. I want to change this to Virat. Let me show you how to do it. This is very simple. I'll just give a comment, that is modify objects. The way to do is you just say the object name, that is s1, followed by the parameter, that is name, equal to, let's say, Virat. Now if I print s1.name, I'll have Virat instead of Harry. Okay. Now if you want to delete the object properties, let's say I want to delete one of the properties, let's say I want to delete name property of the student. To do that, I can use the del keyword followed by the object name, that is s1, and say s1.name. Now if I print s1.name, it will throw an error saying student object has no attribute name, because we are first deleting it and then we are trying to print it, and hence Python cannot recognize this attribute name. Now you can also delete objects, that is all the objects, using the del keyword. So this means we can delete both the objects that we created above, which is name and date of birth. So the way to do is I'll just say del s1. So it will delete all the objects, that is s1 in this case. I'll run this, and then let's say I want to print s1 dot date of birth. You see it here, Python says name s1 is not defined because we deleted it. Cool. Now coming to the final section of the demo, we're going to create a simple class with init method again. So this time my class name is, let's say, animal. Give a colon, and then I'll write my init method using the def keyword. I'll say self comma name, that is the name of the animal, as the parameter. I'll say self dot name equal to name, and then I'm going to create another function called def, which is essentially a welcome or a greet message, and that has a parameter, that is self. I'm going to print the greet message or the greeting. I'll say hi, my name is, give a comma, and then say self dot name. Now I'm going to create my object a1 to initiate my class. So I'll say animal, which is the class name. Let's say the name of the animal is puppy. Then I'm going to say a1 dot greet. I'll use parenthesis. Let's run it. There you go. You see here we have a message printed, hi, my name is. Then using the self dot name argument of the parameter, we are passing in the value, that is puppy. Alright, so that was a demo session on Python classes and objects. So we saw how to create a simple class in Python, and then we saw how to create objects to call a class, and then we saw how to use the self parameter. After that we saw how to print a message that is present in the doc string of a class, and then we checked a few examples on using the init method in a class. Then we learned how to modify objects and delete objects in a class, and finally we saw another example on init method. Alright,
Let's glance at the topics. Object-oriented programming in Python, some major principles of object-oriented programming, and then we will touch upon topics like class in Python, objects, methods, inheritance, the concepts of inheritance, the different type of inheritance, then the definition and examples of polymorphism, encapsulation, and abstraction. So all these topics will be supported with examples and the relevant terminologies and definitions. Now, what is object-oriented programming? Python is an object-oriented language like any other programming language like Java, C++, and the object-oriented programming language concept is not new, and each and every mature programming language has these concepts imbibed in it. Now, the concept of object-oriented programming in Python focuses primarily on creating project objects and making reusable codes. So whenever we start programming at a large scale or for a big project, it is very important to identify the objects within that particular project which you want to define. Now, for example, in this presentation, what you are seeing is that we are covered with full of objects like car, dog, tiger, tree, or a balloon. So these are typical examples of objects which you encounter in day-to-day life. Now, what are the major principles of object-oriented programming? So these are the different kind of terminologies. Classes are there. There are objects. There are methods. Then on these classes and objects, you apply inheritance, polymorphism, encapsulation, and abstraction. Now, what is a class? Class is nothing but a collection of objects, or we can say a user defined data type, right? So basically, it's a complex data type which has a collection of objects, and within the objects, you have primitive data types like int, string, float, etc. So a class also holds the methods, the functions which basically perform operations on these objects, right? And also it also holds on to the attributes of the objects. So let's see with an example, right? So if you have an employee class, then it would contain attributes and methods such as email ID, name, age, salary. These are the attributes. And on the methods like, perform task, give presentation, increase salary, etc., etc. These are will be the methods. Now let's talk about what are objects in Python. Now, object is known as instantiation of a class, right? An object is a group of interrelated variables and methods. So when a class is defined, only the description for the object is defined. Therefore, no memory or storage is allocated at that point. So for example, if you see in this, motorbike is a class, but the different objects of that class are different kind of bikes by different brands like BMW, Suzuki, Royal Enfield. So they all have inherited the attributes of the class motorbike, and then on top of it define certain variables, additional variables and methods on top of it to enhance the motorbike and make it look different or function differently. Now, what are methods in Python? Methods are functions defined inside the body of a class, right? So basically, methods are something which you perform on a attributes of a class, right? Method is a function that is associated with an object. So you create an object of a class, and on that object, then you can execute those functions. In Python, a method is not unique to class instances. Any object type can have methods. And the methods define the behavior of an object. So that's why a BMW motorbike will be different from Royal Enfield, because the behavior is different. The methods are different. So if you see the example over here, you have a class bike, and in that there is an init function which will get invoked when you initialize the object of class bike, and then you can set the brand name and the year of manufacturing for that particular object. Now, inheritance. What is inheritance? Inheritance is something which you derive from a parent. So, inheritance is like creating a new class that uses all the properties and behavior of another class. Now, the new class is called the derived class or the child class, and the existing class whose properties are inherited is known as a base class or parent class. It provides, and the basic functionality, the usage of inheritance is that reusability of code. So if anything is defined in the parent class, then you don't need to rewrite that particular code in the child, you can just inherit it. So as I mentioned, let's take a look at the different types of inheritance which are available. You have single level, in which only one child is inheriting the properties and the attributes from the parent. Then you have multi-level, in which first child has inherited from the class A, class B has inherited, and then you have another class C which is inheriting from class B. So this is an example of multi-level, and we will be supporting all these concepts with an example in our Python notebook. Then there is hierarchical. Then there are two different classes which are inheriting from a single class, and then multiple inheritance, that single class is inheriting from two different parents. So these are different set varieties of inheritance basis what is the demand, what is the business requirement, you can define. Now what is polymorphism? Polymorphism in Python, what does it means? Polymorphism consists of two words, poly and morphs. Poly means many and morph means shape. So basically it means many shapes. So it means using a familiar interface for multiple forms, right? So you can use a single name of the method and which can perform different behavior based on the object in which it is invoked. So in simple terms, we understand that a task can be performed in various ways. Let's support it with an example. Like you have a plus operator. Now the plus operator can be used for integer data types to perform arithmetic operations, whereas when you use plus operator to in string data types, it can be used for concatenation. So it's a very typical example, very good example in terms of how an same operator can behave differently basis what data types are being used. Now let's talk about encapsulation. Using OOPS in Python, we can restrict access to methods and variables. So basically in Python you can create something like as private variables, but of course you can't use a private keyword unlike Java. So in Python we use underscore or double underscore in order to define private attributes. So basically these attributes can be only used within the class and cannot be exposed outside a particular class. So we will see this with an example. Now, what is abstraction? Data abstraction and encapsulation are often used as synonyms. Abstraction is used to hide internal details and show only functionalities. For example, you know how to turn on or off a light using a switch, but you don't know what is happening behind the socket. Similarly, an abstract class cannot be instantiated, which means you cannot create objects for this class. You can only define the methods which have to be implemented by the classes which are inheriting the abstract class. So basically abstract class provide only the method signatures and rest the other functionalities, and the implementation has to be done by the child classes. So let's now move to the our Jupyter notebook and we will start performing certain examples. Now, as we are saying, like Python has objects. So let's create an object. We will create a class bikes over here. And within the class, we will define the init method. And in the init, we will instantiate two variables, brand name and year. Now we will create an object of bike, which we are calling as BMW, and another we will create an object called Ducati. So what we are doing in this two scenarios is that we are just instantiating the bike object with variable BMW and Ducati. We are instantiating. Now let's print the year and manufacturing year, the brand name and the year for BMW and for Ducati, and let's see, right? So what we have done is we have created an object for bikes, one we are calling BMW and one we are calling Ducati, and how we are differentiating between these two bikes is basis the brand name and the year of manufacturing. Now let's take a look at the example of methods. I'm going to rewrite my init method, and now I am creating a function, a method of top speed and a function of type. Now I'm going to create an object of bike. Now this method, this object bike can invoke methods top speed and type because they belong to the same class bikes. So initially when I created my object bikes, I'm instantiating it with BMW and the year, and then I am making a call to the method top speed, and then I'm making a call to the method type and printing. So basically I'm printing the output of the function top speed and output of the function BMW, form the object BMW which is of class bikes. Now let's take a look at an example of single level inheritance. Let's create a parent class called animal and create a method called sound, and let's create a child class cat which inherits animal, and let me just put a method over here. Here's the indentation. Okay, so now I have object parent class animal, child class cat which has inherited animal, and the parent class method is sound and the child class method is meow. So now I'll create an object called cat, and with this object I'll be able to invoke both child class method and the parent class method. And as you can see, the child class has inherited both parent and child class functions, methods. Now let's take a look at multi-level inheritance example. I'll start off with creating exactly the same parent class called animal. Then I'm already created another class. I'll create same child class cat, and now I'll create another class which will inherit cat class. So cat has inherited animal and cat child has inherited cat. Let's validate its syntax. And similarly now I'll create an object for cat child, and this cat child now can invoke the same methods which are in child, parent, and the super parent. So this is an example of multi-level. This is an example of single level inheritance. Now let's take an example of polymorphism. We are going to create a class parrot and define the function fly and swim. Now we are going to create another class. Mind you, there is no inheritance here. We are just creating an independent class called penguin, and same methods now, the same name, fly and swim. Okay. Now let's make a function in which we will pass an object, and basis that what is the instance of the particular object bird, the corresponding method will get invoked. So let's see. In the method flying test, whatever instance of the bird object will be, the corresponding of method will be called. So now let's create a object of parrot class, and then let's create a object of penguin class. Now in my flying test method, first I'll send a object of instance parrot, and then I'll send the object of instance penguin. So now basis the instance type, when this bird.fly method will be called, it will be called basis the instance. So in the first case, the parrot, it will call this method, and in case of penguin, it will call this method fly. So please note what is the output. The output is a parrot can fly, but a penguin cannot fly. And it has been decided by the Python at the runtime that which particular method to be invoked basis the instance. So it's a very important concept. Now let's take an example of encapsulation. I'll make a class cars, define its init method. Now within that init method, I have created a private variable with underscore underscore max price and given a value of 9 lakh. Now I am creating another function called sell, and in that I am printing the max price. And then I am creating another function in which I am modifying the private variable set max price. So I will pass any value in the set max price, and it will replace the max price which I have set during the initialization at this point. Now let's create an object of class cars. and see if I sell this, then the selling price is 9 lakh, what I had at the set at the time of initialization. Now what I'm trying to do is I'm trying to modify a private variable directly, c underscore underscore max price, and I want to check if I'm trying to create modify a private variable, will it still show me 9 lakh or 10 lakh value? And it's still showing me the 9 lakh value. It means that I can't directly approach or access the private variable. I can only modify it if I access it through a method which is set max price. In this, now I am setting the max price to 1000, and now if I print what is my max price, it will print as 1000. So this is the concept of encapsulation. You have a private variable which is accessible within only the methods of the class. You can't access it directly. Now let's take a look at hierarchical inheritance. I'll create a class employee and create an init method. Within that, you have three variables: name, age, and salary. So an employee with has name, age, and salary. Now I'm going to create a child class called child employee 1, which is inherited from employee, and child employee 2, which is also inherited from employee. So what I'm going to do is I'm going to create a object per child class and print. So this is a typical example in which you have two child classes which have inherited from the single parent, hierarchical inheritance. Now let's take a look at our last concept, which is abstraction. So now I'll create a class car and define a method mileage, but I am not giving any definition to it. I am just giving a signature mileage. The child classes which will inherit abstract class will be giving the definition. So I am creating a class BMW, which has inherited the car ABC car, but given the definition now. Similarly, I am creating another class Jaguar, which has inherited the class car, but now it is giving a different definition. It's printing mileage 25 kilometer per hour, and another class Range Rover, and another class Renault. Okay, so four classes which have implemented the abstract class method mileage in a different way. Now I'll create an object of first BMW and invoke method mileage. So it has method invoked the method mileage on BMW car and printed mileage is 30 kilometer. Similarly, I'll do for Renault, Jaguar and Range Rover. So if you see, the parent class, abstract parent class has not implemented the method but just given the signature of the method, and all other classes have implemented it, and that's the concept of abstraction. We're going to talk about the concept of inheritance, the types of inheritance which are applicable. So the different kind of inheritance which we're going to talk about are single level inheritance, multi-level, hierarchical, and multiple inheritance. And we're going to support each concept with an example. Before we begin this session, I just want to highlight that inheritance is not a new concept in any of the programming languages. Just like in Python, this concept is applicable across multiple programming languages like Java, C++, etc. Now, what is inheritance? Inheritance provides the reusability of a code. It allows you to inherit what you have written in a particular class or a piece of code, and you don't need to rewrite it. You can inherit it. So that is the main purpose of inheritance. It is creating a new class that utilizes the properties and behavior of an existing class. So we will support this with an example. So if you take a look at the syntax, the sample syntax over here, you have a base class and you have certain attributes, functions associated with the base class. And then you have a derived class in which you extend, basically you inherit